So got some important stuff to go over. Because second test, obviously a lot of you are going to take retakes. I was kind of surprised. Not everyone took retakes on the first one, but most of us did really well on the first one. Yep, just grab that. So, missing tests. So I know a number of you were gone. I had like 7 kids in here at like 7 o'clock this morning getting the missing tests done. That's when I do tests. Yep. If you weren't here to take the test, you need to take it. And I do those in the morning. So you need to get here in the morning and do that. So I appreciate those kids getting that out of the way. There was a lot of cross-country kids. And then a student who was sick, they missed it and they were in here. So I get those done first thing in the morning. Tests take longer than lunch. I don't like having you leave and then come back to a test. I want you to do it all at once. And so that's why we do them in the morning. And plus, my lunch times, I do so many other things. I'm working with students, and it's distracting in here, and I have conversations. And so the morning is a good testing environment. So that's when they happen. So Josh, make sure you're listening right now. This is way more important than that. Whatever you're doing, trust me. Okay, makeups. Let's say you did not do well, or you think you could do better on the test. And it happens. I have a system that works. Works for you and it works for me. So this is how I think of it. I've given everyone the opportunity to take a test during class time. And I think that's pretty fair. If you want to do a retake, it's going to be during your time. Okay? And my time. The retakes happen in the morning. First thing in the morning. Early. Because most tests take between 30 to 45 minutes. So that means you have to be here. If you're not here by 7:15, I don't even give you the test. You walk in at 7:25 and ask for it, I say nope. Come back another day. You need to get here early enough so you can finish in that whole time. Then, before you can even do that, before you can even come in, you got to come down during your lunchtime. And we start this process. It's a test correction form. What I do is I release the test to you. You get to get on a computer and you see your test. You see like I got 0 out of 2 or I got 2 out of 4. You see how many points you got. You don't see what the right answer is and you don't even see what you put down. You just see how many points you got. So if you got 0 out of 2, did you get it right or wrong? Wrong. So that tells you I need to fix that. So then what you do here, actually you do see what you put down. I'm sorry. You do see, and you see if it's right or wrong. Then you have to say, okay, you put down, what do you think your mistake was? Okay, it says, explain what went wrong or what you didn't understand. Be specific. So you have to explain what you did and why you, like, what happened. Then over here, you write down how you would do it now. So what this allows me to do, Jay, it allows me to see, do you understand how to do the math? So this is important, Sylvie, because if you come in at lunch, I have the ability to go around and help you. Now, lunch is my time. I'm willing to help you if you're willing to take your time. So it's a good trade. Okay, that if you want to retake, then you do this. Okay, next piece. If you failed, you don't get a choice of not doing this. You have to do this. Because my job as a teacher is to make sure you know the content. I've given everyone an opportunity to show their understanding during class time. So if it didn't work out during that time, okay, I'll come find you if you failed it, and we will go over this together during your time. Sometimes it takes 2 lunches. Sometimes it takes 1. But we do it together. That way I now I'm confident, Allie, that you know how to do it, right? Because that's the whole point. I don't want you to just go home, fill this in, you did it all wrong. No, I want this to be done right. So then I can be confident that when you go take the test, okay, you'll be successful. Because that's the whole point, is that I want you to learn the material. So you guys can use your math brains and be good mathematicians. So, a couple questions. When do I do the test correction form? Olive. At lunch. Okay? If I want to do a retake test, okay, when would I have to come in? Allie?
7.
Okay, 7 to 7:15 in the morning, right? Please schedule with me because I'm not here early every morning. Okay, I'm going to be here Monday because girls have already told me, like, yeah, I'm going to be here on Monday morning. They came in at lunch. They already filled this in. They're done step 1. Now they're doing step 2. They're going to come Monday morning. Okay? They're my couple kids from 3rd hour. Olive.
Me and Ryan failed. When would we come?
Oh, lunch, you come during lunch. Just come down during lunch. And I have focused math in here, and you'll be able to just come in and do it. Totally. Yeah. I totally support you during that time, too. It will make it work. I don't see it happening, but you never know. I don't think it will happen. But. Okay? So it's a 2-step process. Okay? And so I do believe, from my perspective, I feel like this system is going to work a lot better for me than what I did last year. And I think it's going to work better for you, which is cool. Any questions about that? Because that's pretty important. I think you guys need to understand how to do that. And I want everyone to try their best, obviously, and I want everyone to learn the material, and that's what this is for. Any other questions? Rachel?
What's it feeling grade?
Below a 60. Okay? So, you go on Infinite Campus, and it will tell you, like, I don't know, does it tell you percent? It does? Okay. So I'm not even sure. I know it tells you, like, you got, like, a 26 out of 36.
So we're not going, like, by, your score on the test, you're going by your grade?
No, it's your score. So you got it would be like a 25 out of 26 or 32 out of 36. Okay? And you just do that division and you figure out what your grade is. Anything below 26, I think, is a D, and I can't remember what the failing grade was. I think it was a 23, 24. So if you got below that, then I'll be finding you on Monday to start this process. Any questions? Any other questions? That's a really good question. All the grades are in Infinite Campus except for the kids that came in this morning. Okay, I have not had a chance to put those in. Man, I'm like getting tongue-tied today, at least. I'm like, I can't talk. Whew. Okay, and no? All right. Those forms are up here. Okay, they're right up here with the weekly warm-ups and that. Talk to your partner about the warm-up. Go.
So I found the first one.
Does that kind of make sense to you?
That's right. I'm glad you're using this. I have their test, the second part, written part. I've done that.
All right. Yeah. I'll be grading those over the weekend.
Okay. So positive numbers another positive number is making class with a private number. And the negative number.
So what do you think, Carl?
I got the first one. I knew this because 2 negatives.
Okay. Good. Now we're talking. That's better. It's better than cancel out.
5 times 4 and negative 4 times negative 5 are both.
Okay, let's come back together here. So Carl was talking. Carl said, I got the first and the last. They have the same product as an answer. What's product? Cody.
Isn't a product the answer of division?
Answer to multiplication. Yes, correct. So they have the same product. Why? Carl said because a positive times a positive equals a positive, and a negative times a negative equals a positive. So they have the same product. Now, when you think about math vocabulary, it's important that we practice using it because then when we go to write, we use it. Okay? And we know that then we'll be more articulate, more specific. around what we're trying to explain. So when I ask you to talk to your partner or write something down like this, try to be specific. Moving ahead, we're going to talk about Hayden's exemplar. If you did not get an exemplar, they're right up here, so come grab it. Okay, I would like you to look at the exemplar and again, talk to your partner, but before we start talking, there are some key things that you can use. One would be, I noticed that. Like I noticed that Hayden did blah, 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 blah. That's a pretty easy way to talk to your partner. You could agree or disagree what your partner says, but if your partner says something, it's either you're going to agree or you're going to disagree. And so you can use those statements as well. If your partner says, man, I noticed that Hayden, blah, 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 you could say, well, I agree also because, and you could say why. If your partner says something you don't understand, obviously, can you please explain? Like explain it further. Another way I thought about what you just said was another great kind of way to talk about an exemplar. So go ahead, let's use some of those. Talk to your partner about Hayden's work on her reflection. Go.
I noticed that I didn't do as well as she did with the.
That's what it is, and it isn't a community property.
I realized that she said, like, what the answer that kind of like, she also put an absolute value in parentheses to make sure that whoever was reading it knows that she was doing it in absolute value, so they didn't do it a different way or think that it was not an absolute value.
She was doing the brainstorm.
What else you guys notice? What else?
I noticed that she has vocabulary.
Like what were some of the vocab words?
She used absolute value. She used negative and positives.
She's communicative.
Some, that's a huge one in that question.
I also noticed that she
Operation.
didn't,
Operation.
Communicative property.
Okay. What were you going to say, Ryan?
Difference.
It was on the back. She said, it has to be addition because in subtraction, if you move the numbers around, it messes up the difference. And I love that. Another way to think about that would be to say, when you subtract the same two, right, and you flip the operations, the add-ins, you get a different answer, right? And then another way to think about it is when you subtract a positive, it's like adding a negative. So there's a lot of different ways that you can think about saying the same thing. All right, let's come back together here. So you notice, first of all, Hayden's response was loaded with math vocabulary. Had sum, had operation, had difference, had absolute value. Basically all of the really important vocab that I could think of in each of those questions, she used. Why do you think that? Like, how did she, Olive? The problem, yeah. When you read the question, it gives you some of the vocab in the question. And all she did was then reuse it again. It's a super smart technique. And it makes you very articulate because you're using mathematical vocabulary. Do you think Hayden's going to use more math vocabulary the more she uses them in a rank? Yeah. And she'll understand what those words mean more. Okay. I need those exemplars for the next class. If you could return those exemplars, that would be great. Coming down Swivl Creek?
No, on the track.
You were on it. So were you coming down Pex?
I was actually standing messing with my camelback and my pipe.
So it wasn't even at one of the trickier, because when you come down Pex, you got that one little turn wasn't even there, huh?
We put her
That will teach you, huh? All you had to do was click, stop, fix. I know, it's always hindsight's always 2020. Okay. I would like to have your Post-its up here.
We need our name on them.
Yeah. No. Come on up. Put your Post-its up here. And then we're going to look at today's lesson. You need to have 3.2 in front of you. So I'm going to start. You guys are being great at hanging those up. Okay. So on your paper that you collected at the door for 3.2, today we're looking at the multiplication of rational numbers and creating algorithms for those rational numbers. So yesterday we looked at algorithms for integers. So I would like to pose the question, what is the difference between an integer and a rational number? Talk to your partner.
But a rational number is any number. It's opposite.
Almost. Almost, Ben. Almost. That was good.
A positive 7 would be any number that if the number's opposite.
So an integer. I was listening to Ben. An integer is any number, okay, any whole number, and its opposite, including 0. Don't want to forget that. Okay, that's an integer. A rational number is any number that can be written as a ratio. Okay, so what's a ratio? It's a fraction. So what? Can that be written as a fraction? Yes. All I have to do is put one underneath it, right? So decimals can be written as fractions. Boom. So there are some numbers that can't be written as a rational number. Those numbers are like 0.333333 forever and ever and ever, right? You can't write that. So any kind of repeating decimal, okay, cannot be written as a rational number. So today we're taking our knowledge about what we did with integers, and now we're going to incorporate rational numbers. But you know what's great? The same algorithms apply to integers and rational numbers. Exact same. So over here, these are the algorithms we created yesterday. This is what I'd like you to do. Just to get our brain going again, I would like you to give me an example after each one of these. Go for it. Write them down, Ben. Write them down. I know. Come on. You know. Write them down. Yep. Yep.
Positive times 3. Okay. Make positive times 3. 5 times 3.
Do you want the algorithm or the...
No, just the number sentence.
Can I use all the numbers? Because I just did like...
Yeah, that's all I did. All right. So I included my examples up here. So we know that a positive times a positive equals a positive. And then we know a negative times a negative equals a positive. Carl was saying earlier, he said, well, when we were talking about negatives and positives and multiplying them, we know that if you have an even number of negative factors, you're going to get a positive answer. We have an even number of negative factors here because it's 2, so we get a positive answer. Here, we have 0 negative factors, so it's positive. Here, 1 negative factor, there 1 negative factor, so we get negative answers. So those algorithms are going to apply with what we talk about today. Today's a little bit of a refresher with fractions, so I want you to follow along. So here with multiplying fractions, we just multiply straight across the numerators and denominators. Straight across. Fractions are pretty easy in that respect. So I'd go 4/5 times 4/5. And this is how I want you to do it just to begin, Josh. I want you to write this like this so you understand that it's 4 times 4 and 5 times 5. And that's going to equal 16/25. You should have those notes. Once you've done that, once you understand that, oh yeah, we multiply fractions straight across. We don't have to look for a common denominator, none of that when we multiply fractions. I want you to practice on these two down here. But notice, there's one negative down here and there's two negatives down there. Go.
Do we have to simplify?
I did, but...
Oh, and then he wants you to change the imperfection.
So you're going to come up with improper fractions. So we know we see those improper fractions that we can simplify them. What did I do wrong? I know. Shh. Right, I have it in the fraction, but not in the whole number. Right, so here I've got a positive times a negative. What do we know about positive times a negative? Olive, it's a negative because we have an odd number of negative factors, so it should be negative. Now this is what you need to do. So I should have a negative answer, but it's not negative. This is so common. So what you need to always do is just double check. Hey, it's a positive time. It takes 2 seconds. So I got to make that negative. I forgot to bring my negative over to here. Here I have a negative times a negative. So what should my answer be? Okay, I got a positive answer. And you can see the steps that I did. It's 4 times negative 8, that's positive 32, and 5 times 5 is 25. And I simplified it. That's fractions. Fractions are really easy with multiplying. So here we go. Now we're going to talk about decimals. Because again, decimals are rational numbers too, because you can write them as rational numbers.
You can write them as a fraction.
Exactly. So, here, I don't have to line up my decimals like I do in addition. I literally just put my two numbers down and I can do the multiplication. So I've got 7 times 8 is 56. I have a 6, I carry the 5. I get 14, I get 9. So I get an answer here of 196, but I'm not done. I have to recognize that one place value is being held by a decimal, this tenths. So when that happens, I have to take my 196 and I move a decimal from the end one place over because one place is being held. So my answer becomes 19.6 or 19.6 tenths. So now it's your turn to try. We have 2.1 times 5. One place is being held by a decimal. And then we have 3.1 times 6.2. Notice the last one, 2 places are being held by a decimal. Okay, your turn to go. So then 5 times 2 is 10, right? Mm-hmm. So you forgot your 1 there. That's all you forgot. Thank you. Bam. Now you got it. So now go ahead and try this one. This one's a little bit harder, right? Because you got you got a little bit more multiplication to do. Awesome. So here, I've done the multiplication, okay, but I haven't moved my decimal yet. So here, Rachel, we have one place value being held by decimal. So I take this imaginary decimal here and I move it over one place. So that's my new answer, 10.5. So 2.1 times 5 is 10.5. Over here, I did the multiplication. And some of you guys might use lattice. I don't know. Does anyone in here use lattice? Okay, good. You can still do it.
I did this for my.
That's fine, but you can use lattice. And it works with lattice. So here it's being held by 1, and then another 1. So it's 2 place values. So I move it over 2. I get 19.22. So this is rational numbers, using fractions, using decimals, positive and negative. So now I look over here. I got a positive times a positive answer. I got a positive times a positive answer. There it goes. It's been doing this. It's not a big deal. I figured out how to fix it. Bam, look at that. So, today, your work. You are actually going to start off. You're going to start off on these extension problems on page 73. Just do them right on the back, because I want to make sure that we're really good at knowing this stuff. So I assign those today. Once you're done with that, we're going to go to AL, and please explain. It's asked you to explain. B, C, and then we probably won't get down to these, but that's okay. We have 2 days for this lesson. Yeah. I'm going to take attendance, and then I'll be coming around to help out.
Conferences are tonight?
Whoa.
Did you forget?
Oh, I didn't forget.
What are the
I just
conferences
remember
for?
when I was tired.
What are the conferences for?
It's page 73. And there's number 7.
It's to convert. That was good. Something you let me do. We're not talking shoot. Stop. We're talking.
It's not converse, it's converse.
You know from experience?
Make a grown man cry.
Rational numbers are the ones you can put into the desk or ratio. Right?
sir.
Dandy.
I think that should be it. That's everybody. Okay.
Oh, did you already do 49, 51, 52? I want you to start. I want you to start on the extensions. It says explain. That's not explaining. Explain. You don't have to do a ton, but think about math, vocab, okay? That's what I'm looking for. Is that when it says explain, the first thing you should think about is kind of restate the question and use math, vocab. Huh? Communicative? That doesn't quite. Communicative probably doesn't really explain this. Because it's m plus n. So if m is positive and n is positive, you know it's like sometimes or if both numbers are positive, what kind of answer do I get? Bigger positive, what do I get? Okay, explain that. Because it's not. You might want to check this one again. Sure you finished 50 through those ones? 49, 50, 51, 52, 53? See how you answer it. So look, if this is positive, if m is positive, and I'm adding another positive, what's my answer going to be?
M plus 10. All, sometimes or never.
So you just had a little confusion. So this is true. Because, just like you said, and you can write it like this, because you've already done it enough. A small positive plus a bigger positive equals a bigger positive, and a big positive plus another positive, right? Okay. So think about that, and then go on to the next question. Hey, Kevin. Okay, no problem. Yeah. Bye-bye. Okay. I want you to think. There's a term that should be used in 15. A vocab. Super important. Okay, guys. Shoot, I didn't give myself enough time. Okay. Well, I'll talk about these problems tomorrow. I need to give myself more time to go over them with you. Put away. Tomorrow we're going to continue working on this. We have 2 days for this lesson. Please get your planners out. A through E. Right in your planner. Due on Monday. It's on page 68. Man, I love Sean's planner. It's going to be super organized, man. It's cool.
He's got it together this year.
It's cool. He's got his planners just... Okay, 13A through E on page 68. Then your exit ticket. So yesterday you had to write the algorithms for the problems. Today I'm asking you to solve, Josh. Today on your exit ticket, you need to solve this, solve that, and write the algorithm. You're not going to turn them in.
Do I have to write the equation?
But I would be ready to have them looked at. But I'm not looking at them today. I already have the second part of the test to grade. It's going to take me like 3 hours, so I'm not taking any more grading on right now.
Are you going to take them on Monday?
Question.
I don't know why I put myself through it. Say what?
Do we have to write the equation?
Yes, absolutely have to write the equation. So we talked about determining algorithms for multiplying and multiplying positive and negative rational numbers. So we're revisiting it right before you're heading out the door. It's a chord. So here, I have a negative times a negative.
Equals a positive.
That's going to equal positive because an even number of negative factors makes a positive answer. And I've got 2 negative factors. Over here, I have 1 negative factor, so I already know my answer is going to be negative. I have to move that decimal over and make it negative, and I get an answer of negative 12.9. Okay? You want to, and then I need to write the algorithm. Almost forgot the algorithm. Negative times a positive equals a negative. You will want to you're going to keep your exit ticket for this week for right now, because I'm not going to collect it because there's no way I'm going to look at those and grade the. So keep it in your binder. Might check it on Monday. I don't know. I haven't decided. So if you're missing some, you might want to do them. Go online. Okay. Other than that, guys, have a great weekend. Learning.
Not be lazy.